In this video, I'll be going over imaginary and complex numbers. So what are imaginary numbers? Imaginary numbers give us imaginary solutions to equations that do not have any real solutions by using the number I. Let's look at an example. So for x squared equals -1. This has no real solutions. But if you look at x squared equals 1, so for x squared equals 1, there are two real solutions, positive 1 and -1. If you put positive 1 for x squared, it's never going to equal -1, and the same for -1. So let's look at x squared equals -9, x squared equals 9. So for x squared equals -9, there are no real solutions again. But for x squared equals 9, again, there are two solutions, positive 3 and -3. We can express the solution for x squared equals -1 with I. Before we solve for x, something that you need to know is that I equals square root -1. We'll go over the other powers of I later, but this is something that you need to know for solving for x squared equals -1. So first we're going to square root both sides. So it will be x equals square root -1. And as you see, x equals square root -1, I equals square root -1. So x equals I. Now let's look at x squared equals -9. So again, we're going to square root both sides. That'll give us x equals square root -9. Now we can simplify square root -9. So first we're going to take out the negative end of the 9, so it will be square root -1 times 9. And that will equal 3 square root -1. And again, I equals square root -1, so x equals 3y. Now some of you may be wondering why it's not plus or minus I or plus or minus 3i. Well, first you must realize that by writing x equals square root -1, you are breaking the rules of math with real numbers. There can never be a negative in a square root. So that same plus or minus rule does not apply with imaginary numbers. For x squared equals -1, x can only equal I, and for x squared equals -9, x can only equal 3i. Complex numbers are a combination of real and imaginary numbers. They're complex. The standard form for complex numbers is a plus bi. So a plus bi. So some examples of complex numbers are 17 plus 5i, 25, -8i. Now, for 25 and -8i, okay, so for 25, the bi is not present. Well, actually, it's there, but it's like 25 plus 0i. And then for -8i, it will be -8i plus 0. These are only a few examples of complex numbers. There are infinite complex numbers. Something pretty important are the powers of imaginary units. So as you all know, I equals square root -1, and then I squared equals -1, I cubed equals -I, and I to the fourth equals 1. And then the pattern continues for the rest. So then I to the fifth equals square root -1, I to the sixth equals -1, I to the seventh equals -I, and I to the eighth equals 1. So as long as you know the first 4 powers of I, you'll be able to figure out the rest. And even if you only know the first 2 powers of I, that I equals square root negative 1, that I squared equals negative 1, you will be able to figure out I cubed and I to the 4th. Let's go over some examples of tougher powers. So for example, I to the 25th. Well, I to the 25th equals I, and I equals square root negative 1. So I to the 25th equals square root negative 1. How about I to the 79th? Well, I to the 79th would equal I cubed. So therefore, it will equal negative I. And now I to the 44th. That will equal I to the 4th. So that will be 1. And then I to the 22nd. Now that will equal I squared. And that equals negative 1.